So for those of you who have joined us on YouTube and Facebook, we'll go live in about a minute. Okay, so we are live now. So good morning, good afternoon, or good evening, as the case may be, to all of you who have joined us live today from various parts of the world and also from different time zones. India Bioscience is honored to host this special webinar today by the International Union of Biological Sciences, IUBS, to commemorate its completion of 100 years of promoting excellence in biological sciences. To kickstart the webinar series, today we shall have a conversation with Professor Rattan Lal. He is the 2020 World Food Prize laureate. And in this conversation, he would address the intimate connection between nature and human in a short talk titled Forgetting How to Tend the Soil. This talk will be followed by a live interaction between Professor Lal and Alison Meston from the International Science Council, who will be moderating the session. So before we get started, we will go over a few housekeeping instructions which will help us with our experience and interact better as we go along. Whether you have joined us using the web app version of Zoom or the downloaded desktop app, at the bottom of your screen, you'll find three icons. As you see on my screen share right now, the one to the left is the chat icon. The one to the right is the Q&A box. So if you have any questions for the speaker during the course of the webinar, click on the Q&A box, and when the box opens up, type in your questions. You have the option of sending in your questions anonymously if you wish so. We will be sharing relevant links with you via the chat. However, you would not be able to communicate with us via the chat. So if you have any questions, do use the Q&A box. This webinar today is also being simulcast via live stream on two platforms, YouTube and Facebook Live. If you're watching us via Zoom, YouTube, or Facebook, our team will share these three links with you via the chat. If you have any audio video issues with one, you have the option of switching to another. You may also submit your questions to the speaker via any of these platforms, and our team will collate those questions to place it in front of Professor Lal. You will also find this streaming on the homepage of the India Bioscience website at www.indiabioscience.org. So to begin with, we want to know who has joined us. So we will just do a brief audience poll. So if you see a poll launched on your screens, please take a moment to let us know a little bit about yourselves, where you're from, and what you do. For those of you who have joined us via Facebook and YouTube, our team will share a Google form with these poll questions so you can participate as well. We'll take about 20 seconds for the responses to come in. About 75% of you have responded. We'll close the poll in 3 seconds. So let me end the poll now, and I'll share the results. Most of you, 78% of you, are from Asia, also from Africa, across continents. And most of you are researchers, that's 21%. We also have a good population of students across the spectrum, bachelor's, master's, PhD. We have some educators as well. So again, welcome, warm welcome to all of you who are joining us live. We will begin with an address by Professor Shashidhara, who will give an overview of today's webinar. Over to you, Sashi.
Thank you very much, Lakshmi. On behalf of International Union of Biological Sciences, I again warmly welcome all of you for this webinar. And before I forget, I should thank not only the speaker and Alison Meston, who is moderating the session, all the people who have done a lot of background work, Smita, Lakshmi, Tejaswini, Shreya, and others. And thank you very much to all of them for putting this effort. I also want to thank the Executive Director of IUBS, Nathalie, who has also put in a lot of effort in promoting this webinar. And she's the one, of course, steering all the IUBS activity. I will take 2 minutes. I won't be between you and Professor Lal, whom we are all eagerly waiting to hear, just to introduce IUBS, International Union of Biological Sciences. It has about 100 years of glorious history of promoting international collaboration for research and education in biological sciences. It started in 1919. Unfortunately, it's a coincidence of 1919 is the year of Spanish flu pandemic, and we are now experiencing another pandemic 100 years later. It's IUBS specifically focusing in the domains of ecology, evolution, genetics, bionomenclature, biodiversity, public health, agriculture, ecosystem function, and services. In the past few decades, IUBS is working with other science and social science unions in addressing the challenges posed by global warming, deforestation, increased human livestock migration, rapid urbanization, invasive species, new epidemics. In fact, it started focusing on new epidemics more than 20 years ago, and little we knew that we would be in the middle of a pandemic in 2020. Recently, IUBS also has set up a working group on zoonotic diseases. When IUBS decided to start a webinar series to commemorate its centenary year, we first thought of Professor Rattan Lal, whose work is most influential in the area of sustainability and all that IUBS stands for. And thankfully, Professor Rattan Lal agreed, and our very first speaker whom we thought of is the speaker of today and inaugurating our webinar series. Without much ado, let's move on to Professor Rattan Lal, and we are all eagerly waiting to hear Professor Lal. I request Dr. Alison Meston, Head of Communication Division of International Science Council. In a way, it's a mother union for all of us. We all look forward to the support of international science unions in all of in every front aspect of our work. And Alison, please take over. Thank you very much.
Thank you very much, Shashi, and you've awarded me a doctorate that I don't have, so I'm just Alison Meston. I am the Communications Director for the International Science Council, and it's a pleasure to be moderating today's session. The International Science Council, the ISC, is a non-governmental organisation, and we have a unique global membership that brings together scientific unions and associations and over 140 national and regional scientific organisations. And this includes the IUBS, who is a proud member of the ISC, and we wish you a happy centenary. The vision of the Council is to advance science as a global public good. Scientific knowledge, data and expertise must be universally shared, and its benefits shared by all. This practice of science must be inclusive and equitable, also in opportunities for scientific education and capacity and development. So I think it's fitting that we start this lecture series today with Professor Rattan Lal. He is a distinguished university professor and director of the Carbon Management and Sequestration Center at The Ohio State University. He is an adjunct professor at the University of Iceland and holds a chair of soil science and goodwill ambassador position with the Inter-American Institute of Cooperation in Agriculture in San Jose in Costa Rica. He's been president of the Soil Science Society of America and the International Union of Soil Sciences. He researches soil carbon sequestration for food and climate security, conservation, agriculture, and soil health. He's authored more than 955 journal articles, has mentored 360 researchers, and is the laureate of many awards, including as a Goodwill Ambassador for the Chair in Soil Science. And in 2020, as we know, he won the Distinguished World Food Prize. You might like to know that we're halfway through the International Union of Soil Science decade, and I'm heartened to know that biological science has a deep connection to social science, with Professor Lal recently writing for the ISC in our project on rethinking human development. Connecting with nature and understanding humankind's place with this intricate and delicate web is becoming more and more important as we move forward in this century. It is my pleasure, on behalf of the International Union of Biological Science, our media partners, India Bioscience, and the International Science Council, to welcome Professor Rattan Lal to give us his lecture on preserving our soil. Professor, it's over to you.
You're on mute, Rattan. You have to unmute yourself.
Alison, thank you for that introduction. I really appreciate it. And I also want to thank IUBS, Professor Shashidhara, and colleague Natalie, and especially ISC. We have looked forward to working with you, and today is a very good opportunity for that. I appreciate all the arrangements made, Sashi. It's a great honor to be opening this series on a very auspicious day, Mahatma Gandhi's anniversary. So it's really a very auspicious from that perspective. I'm going to share screen so I can begin my presentation. Let's see. Okay. Can you see the screen?
Yes, we can.
Very good. Thank you. So the title, as was suggested by Professor Shashidhara, taken a quotation from Mahatma Gandhi's ideas, where he said to forget how to dig the earth and to tend the soil is to forget ourselves. And I think that sums up everything, the importance of soil to humanity and to nature. I want to go back to about 10,000 years ago with the beginning of agriculture, maybe in the Near East, the so-called Fertile Crescent, about 9 to 14,000 years before present, domestication of fine corn, emmer, barley, pea, vetch, lentil. In northern China, rice, 9,000 years ago, Papua New Guinea, 6 to 9,000 years ago, sugarcane root crops, central Mexico, Aztec, Mayans, 7 to 8,000 years ago, maize, squash, gourds, beans. Indus Valley, 7.5 to 11,000 years ago, wheat, barley, jojoba. West Africa, about 5,000 years ago, yam and cassava. Horn of Africa, 5 to 7,000, teff, coffee, cucumber tree, yabe nut. And Eastern North America, the Cherokees, 4 to 5,000 years ago, cranberries, chenopod, marsh elder, maple sugar, tobacco, squash, sunflower, knotweed, little barley, maygrass. And in Western North America, Pueblo dweller, about 6,000 years ago, amaranth and pine nuts. And finally, as an example, Incas in South America, 7,000 years ago, potato, beans, cocoa. This agriculture, what we call the Neolithic revolution, changed the planet tremendously. We had evolution of human systems over that period of time, Paleolithic, the tribes, hunter-gatherer society, the stone, fire evolution, all the way from 2.5 million years ago, 2 to 20 million population total during that period. Neolithic period, when the agriculture began about 10,000 years ago, 12,000 years ago, the population eventually in that era became 900 million. Then we had carbon civilization, the present era. And you notice from Homo erectus to Homo sapien, I call it Homo carbonapiens, the carbon civilization based on fossil fuel. We developed scientific advances, and the population, 7.8 billion at present, destined to be probably 11 billion by the end of this century. And therefore, humans have become a force transforming the biosphere. And that's what Paul Crutzen and others call the Anthropocene. So we are in the Anthropocene. Sometimes the Sanskrit literature calls it Kali Yuga, meaning is the same thing. Anthropocene is more scientifically known in the Western society. As a result of that change in population, which I gave you an example, We had from very small cropland area, about 130 million hectare in year one, to about 1.5 billion hectare at present. We have pasture land area from 100 million hectare to 3.5 billion hectare. Irrigated area, nothing at that time, to about 350 million hectare at present. Drastic transformation of the landscape. And therefore, civilization's impact on soil and soil's impact on civilization cannot be overstated. In fact, the true democracy cannot survive in a country where a large part of the people are hungry. That's a very important concept, hunger and democracy. It was the superlative productivity and durability of the soil which made the first Egyptian civilization possible because of the Nile Valley. The fall of the past civilization, many of them, which I'll give you an example very shortly, was primarily due large part to bad management of the soil and the landscape. And that's a very important statement, the mismanagement, land misuse and soil mismanagement. Therefore, that led to the collapse of many once thriving historic civilization. Sumerian in Mesopotamia, 10,000 BCE, salinization of the land created problems for them. Harappan in Indus Valley, 2000 to 3000 BCE, desiccation, desertification, wind erosion created the problems for them. Incas, Andean region, 750 to 900 CE, soil erosion, now we know it, has been a problem. Mayan in Central America, 750 to 900 CE, also soil erosion causing problem. Exum, northern Ethiopia, 100 to 600 CE, ecological degradation led to the extinction of that civilization. And of course, the Roman in the Mediterranean, 27 BC to 400 AD, exhaustion, fatigue, degradation of the soil health and soil quality. These once mighty civilizations perished because they took their soil resources for granted. I think there's a lesson to learn. Green Revolution since the 60s, a great success story, which saved hundreds of millions of people from starvation. A salute to Dr. Norman Borlaug and his colleague, Dr. Swaminathan and others. The global population between 60 and 2020 increased 2.5 times from 3.1 billion to 7.8 billion. But the cereal production increased 3.3 times from 880 million ton to 2.9 billion ton, almost 3 billion ton at present, 3.3 times. Therefore, the per capita cereal production increased 32%, 284 kilogram to 376 kilogram. That is a remarkable success story. Malthus would not believe, even if he were to see at the time when he developed his concept, population was only 1 billion. This miracle of the Green Revolution happened because of certain inputs into the agroecosystem. Nitrogen fertilizer went up 9.2 times between 1961 and 2019. Phosphorus fertilizer 5 times, potassium 5 times, pesticide drastic increase. You divide anything by zero by whatever, you know what that means. Irrigation 2.5 times from 140 to 300 million hectare. So there is a tremendous inputs of chemicals, pesticides, and water into the agroecosystem. Excessive plowing, deforestation, exposed area to degradation. Right now, almost 1/3 of the ice-free land is degraded to some extent, 3.5 billion hectare of it. And out of that, 1 billion hectare more is by water erosion, 0.6 by wind erosion, salinization about 0.9, quite a lot of area. 20% of the irrigated land is subject to secondary salinization. And the problem is increasing. 36 billion tons of sediments carried by world rivers into the oceans annually. Soil area finite, the good quality land because of increase in population is decreasing. So in a way, we have a peak soil syndrome. We talk about peak oil, peak any other resources, minerals, whatever. Indeed, we do have peak soil as well. We have endangered soil. We have extinct soil, just like extinct species. We just don't know about it. Appropriate land area per person to meet the essential need of humanity is 0.25 hectare. In many countries at the moment, the per capita arable land is 0.05 hectare. And that has caused the soil refugees problem, that has caused the land grab issue, the civil unrest, many social problems, and political instability has been caused by the scarcity and mismanagement of soil resources. In addition, we have a climate change issue. Remember, I mentioned prehistoric 12,000 years ago when agriculture began. Since that time to Industrial Revolution 750, approximate estimate is that the land, forest, and soil together lost 320 gigaton of carbon into the environment. Since 1750 to 2018, we have lost another 235. So total to date, from land use conversion since the beginning of agriculture, we have lost roughly 535 gigaton of carbon from vegetation and soil into the environment. Fossil fuel began in 1750. From 1750 to now, 440 gigaton. This number is more credible than the other estimates are. Therefore, the cumulative emission from 1750 to 2018, 440 plus 235, 675 gigaton, approximately 75% of that came from fossil fuel, 25% from land use conversion, soil and vegetation. And that loss from land use has very strong impact on many ecosystem services: food, feed, fiber, fuel, shelter, environment, climate change, all of those. And the difference between fossil fuel and land use is that with proper adoption of restorative land use and sustainable agriculture management, some of the carbon that we have depleted can be, and in fact must be, put back. And I'll talk about that in a moment. So as a result, the wildlife decline, this report just came out very shortly, the wildlife index, tremendous decline between 1970 and present. And at the same time, if you look at equivalent to 1.9 million square kilometer land lost, 1 million wild species threatened by extinction, 1.3 billion tons of food wasted, many other impact of humanity on ecosystem and landscape. That brings me to the idea of soil. Soil is a living entity. Indeed, 25% of all biodiversity is in the soil's top layer. A fertile soil is a home of millions of organisms. Charles Kellogg from USDA, he stated matter-of-factly, essentially all life depends on the soil. There can be no life without soil and no soil without life. They have evolved together. And if I may add to what Charles Kellogg said, rhizosphere at a nanoscale, the root-soil interface, is the only site in the universe that we know where death is resurrected into life. Soil has the divine powers to resurrect death into life through mineralization of biomass and uptake of the nutrients by the growing plant roots. Here is an example. You got plant roots, you got a clay particle absorbing the cations from the soil solution, and the mineralization of organic matter releases these cations and anions, which are absorbed by the plant roots, and the life begins again. Therefore, rhizosphere, in a true sense, the only known place where death is resurrected into life through, you might call it, the divine powers of the soil. That brings me to the idea of what is soil health. Soil health is soil's capacity as a dynamic and biologically active entity with a natural and managed landscape to sustain multiple ecosystem services, such as net primary productivity, food and nutritional security, biodiversity, water purification, renewability, carbon sequestration, air quality, atmospheric chemistry, elemental cycling, and above all, the human well-being and nature conservancy. The nature conservancy itself all depend on soil and soil health. Sir Albert Howard, he was president of the Indian National Science Academy in 1920. His lecture to the Indian Science Academy, the title was "The Health of Soil, Plant, Animal, and Human is One and Indivisible." Some of us since then have added "and ecosystem." So the health of soil, plant, animal, human, and ecosystem is one and indivisible. Sir Albert Howard also had a law of return, and the law states that substance we take from nature must be returned to the place from which it was taken. You cannot keep taking things out of nature without putting them back, and that is what causes degradation. So in terms of sustainable soil management, we must replace what is removed. We must respond wisely to what is changed, and we must be able to predict what may happen from both anthropogenic and natural perturbations and take action to mitigate or adapt whatever the situation may be. From that point of view, what I mentioned in the very beginning, the Green Revolution, which was essential at that time, but in view of all these environmental impacts that I have indicated, what should the current Green Revolution look like? I think from the point of view of the problems that we have been facing, it has to be soil-based rather than seed-based per se. Seed and soil go together. It's not either or. We got to have both. Soil resilience must be improved. It must be ecosystem-based. Eco-efficiency of the input must be improved. It's not a matter of adding more fertilizer and pesticides and water. It's the efficiency which is the important part. It must be knowledge-based, science and management-driven. And that's the idea we are talking about, eco-efficiency. One of the possibility is conservation agriculture. Here are my experiments from Africa, Nigeria, 1970 and 71. Leave the crop residue, do not disturb the ground, follow a complex rotation, cereal and legume without plowing the ground. And this concept has not been widely adopted yet. The other part which gave these results long-term basis from many parts of the world, especially the conservation agriculture in combination with cover cropping and rotations involving legumes, is the idea of CNPK. Soil fertility not by NPK, but by CNPK. If you add biomass carbon into the soil, the need for NPK may be progressively decreased, maybe even eliminated in some cases. So that is the idea, carbon-based management systems, so that we can minimize the dependence on chemical. And the amount of carbon that we need in soil for optimum productivity is somewhere organic matter content of 3 to 4%. That is the optimum. Unfortunately, in many soils of developing countries such as India, South Asian countries, and Sub-Saharan Africa, we are somewhere about 0.5%. In many cases, I've seen 0.1%. And then we try to improve the situation by adding extra chemicals. And that's a symptomatic treatment of the problem, leading to many chemicals leaked out into the environment and causing a problem. Now, if in depleted soils and degraded landscape, remember I mentioned how much carbon we have lost, almost 555 gigaton together from soil and vegetation. If we were to adopt ideal land use and soil management, it is possible to put back in soil about 2.5 gigaton of carbon per year. Technically possible. Between now and 2100 in soils of the world, it is possible to put in about 175, 180 gigaton. In vegetation, another 150 to 160 gigaton. Between now and 2100, over this 80-year period. And the technical drawdown potential of atmospheric carbon dioxide, if we were able to do that through political willpower, through translation of known science into action, we could probably draw down 150 to 160 parts per million of CO2 over the next 80-year period. Even if we were able to do half of that, and at the same time improve the quality of agricultural produce and nutritional value of it, it would be really ideal. And the reason is because of recarbonization of the biosphere, vegetation, soil, is really the engine of economic development. It has to be. Water resources, quality and quantity, algal bloom issue, the drought flood syndrome, the climate change mitigation adaptation, the food security, both quantity and quality, the biodiversity, both above and below ground, they all depend on our ability, our willpower, our governance, our management to recarbonize the biosphere that we have lost carbon as much as 500 to 600 gigaton. We should have a target, perhaps even half of that or 1/3 of that, we should at least try to do it, implement in recarbonization. I hear many times that we need another 250 million hectare of land to feed the population by 2050. I completely disagree. We already are cultivating 700 million hectare of land area under cereals. If we did the better agriculture, if we improved the yield gap, which we exist quite a lot, for example, grain yield of many crops in India can be doubled. Grain yield of many crops in sub-Saharan Africa can be tripled or quadrupled with known technology. So it's not a question of bringing more land into cultivation. The idea is how to decrease the agricultural land and return some back to nature. My hope is that we will improve agriculture in such a way, rather than bringing 250 million hectare more, we will return 200 million hectare back to nature. While doing that, we also reduce dependence on fertilizer from 200 million tons now, hopefully no more than 100, maybe even less. And at the same time, the cereal yield nationally, now 3,000 kilogram, can be perhaps doubled or even more than double by improving the so-called eco-efficiency. Let's return some land back to nature. Let's reduce inputs of chemicals and pesticide. Let's reduce inputs of water, and let's do the agriculture the best way by using the best soil and minimizing the environmental pollution that unfortunately is linked with agriculture. It need not be the case. Sustainable development goals, unfortunately, were already derailed, and the pandemic has derailed them, even sidetracked them more. And yet the solution to sustainable development goal, ending hunger. Number 2, how can you do that without improved agriculture? Climate action, I indicated how much carbon we can put back in the terrestrial biosphere, both vegetation and soil, life on land. Land degradation neutrality. By 2030, we should have zero net land degradation. You've got to have better management of the terrestrial biosphere to achieve that sustainable development goal. Ending poverty. When you have 60-70% of the population in some developing countries based on agriculture, eliminating poverty means improving income of the farmers. It has to be, otherwise not possible. Good health. Remember the dictum, the health of soil, plants, animal, people, environment, one and invisible. Nutrition, healthy food must come from good soil. That's where the human health depends. Clean water. The so-called dirt is the best media to purify the dirty water. All the water filtered through the soil is purified. The solution to algal bloom lies back on the land. Make sure the water infiltrates through the soil into the stream and into the lake. Renewable energy, all of these depends on this. I've been very pleased to hear a new estimate of world population. It came out just about a week ago. UN projections of last year indicated the current population, 7.8 billion, expected to be 9.74 billion by 2050. But by 2064, according to one estimate, the population began to decline to 9.7, while the UN estimate is 10.3. And by 2100, a difference in population of 2 billion. I hope that we will make it possible to follow this trend in population. How? Through education, through improving income and prosperity. And when it is talking about education, it is the education of the women. They must be in power of their own destiny. They can control the population. Education is the solution. I think with that, some of the things that we are talking about, anthropogenic effect, would really be less. It's very befitting that I close with Gandhi's ideas. We began with this, and today is his anniversary. Gandhi listed 7 sins of humanity. Number 1, wealth without work. By the way, each one of these are as valid today as they were when he wrote in his book, My Experiment with Truth, in the 30s. And I think they will be valid even a century from today. Wealth without work, pleasure without conscience, knowledge without character, commerce without morality, a very important thing, especially these days. Politics without principle. I want to repeat that during this election era. Politics without principle. Religion without sacrifice. And number 7, science without humanity. Science must address human issues. If not, we are not doing what we are supposed to do. Science must be translated into action to address human issues. I calculated, based on this year's data, what is happening in the world today. If you take the death from hunger, 3.1 million people dying every year, that translates into 17.3% dying from hunger every minute. Deforestation, 23 hectare every minute being deforested. Fresh water withdrawal, 9 million cubic meter every minute. Energy consumption, 1.25 petajoules. Peta is 10 to the 15 joule per minute. New motor vehicles, that's a progress, 190 every minute. Urban encroachment, 4.7 hectare of most fertile land going under ceiling, new building, roads. And soil degradation, 23 hectare every minute. Carbon dioxide, carbon emission, CO2C, 21.9, 22 gigagram every minute, billion gram every minute. If Gandhi had seen the statistics of today, 2020, I believe he would have added something to his list. And I think you can guess as bad, really better than what I can. But I think Gandhi would have said technology without wisdom. The difference between poison and remedy or the medicine is a dose. We may need fertilizer, we may need pesticide, but it's the indiscriminate use of those things which makes them poison. That's what technology without wisdom is. Education without relevance. We want to prepare our younger generation to address global issues, such as the pandemic. How did that happen? How can we stop it? And preparing the younger generation to address global issues, especially the issues that look at, consider, improve, restore the future of the planet Earth itself. Humanity without conscience. I think when you see people jumping into the Mediterranean or going elsewhere because the land from where they came cannot support them, and we do not care that is definitely an issue that Gandhi would have said. Humanity without conscience is forgetting being humanity. With that, I thank you so much, Alison, Shashi, for giving the opportunity to talk to this very illustrious group. Thank you.
Thank you very much, Professor Lau, and I think you've given us a lot of food for thought, particularly on that last slide with regards to technology and humanity, and what would Gandhi have added if he were alive today. And I think this is a really nice segue into one of the first questions that we have from our audience, because it's actually about Gandhi. This is a question from Srijit Mishra, and they ask, what would Gandhi have done to address agriculture, including food and nutrition security, during the current pandemic?
Excellent question. And I think Gandhi would have probably emphasized that one of his own statement in which he said, Mother Earth has enough for everybody's needs, but not enough for everybody's greed. So that's one part. Let's take from Mother Earth whatever we need and no more. That would be one message. In agriculture, let's take from soil and put back to soil what we take away from it. So the idea of a law of return. Gandhi, I am sure during this pandemic time, would have focused on strengthening the local production system, the urban agriculture, the home garden. Uh, I think urban agriculture would really help. Even if you do not have a home garden, you're in a flat, even a couple of small boxes in which you see things. It's not only that you produce cucumber, tomato, beans, radish, carrots, whatever. Uh, Simply to see a plant grow has a therapeutic impact on humanity. And especially during this very uncertain era in which humanity is suffering a lot from anxiety, watching plants grow and being close to nature would be very, very critical. And I think Gandhi would have supported that. Strengthening local food production system, be self-reliant.
So that takes me to the next question, and I think it's phrased in a really interesting way. Andy Gulliver from Australia says there is increasing knowledge about the gut microbiome and its effect on the human and physical mental health and well-being. And he's asking, can we draw an analogy with the soil and the plant, and perhaps regarding the soil as the stomach of the plant and the soil microbiome affecting the well-being of the plant?
I think that's a very good analogy, really. That goes back to how the soil health is interconnected, the nexus between the health of soil, plants, animal, people, and the environment all together, and indicating that soil could be the similar to the guts in the intestines of the humanity. Uh, David Montgomery, many of you know, wrote the book Dirt. I have heard him talk about a seminar that plant root and human intestine, just a reverse plant root, how the nutrients are being absorbed and how the biota in the system, biome in the human digestive system acts. I could not give any more support to the idea that the questioner is asking, that the link between the microbial population in soil and its impact on soil health being translated to that nexus approach to human health is really very critical. I want to put in a PR very quickly. I am going to teach a class from January in combination with doctors and epidemiologists and veterinarian, and 2-3 are doctors, one veterinarian, one plant virologist, one health course, exactly talking how to bring human close to nature and find nature-based solution to issues such as pandemic that we are now suffering from.
Thank you, Professor. So I want to now spend a bit of time talking about climate change, because we know at the moment we have got key threats coming from all corners. One, obviously, is this global pandemic that is affecting many of us across the world. But the second and next threat, as these crises become bigger, is climate change. So the next few questions are going to concentrate on climate change. And the first question is quite a broad question, and then I'm going to bring it down a bit further. So Joyati Otegri from Pune is interested to know about the impact climate change is going to have on food security. It's a very general question, so maybe we can give some case studies or examples.
Yes, I think every 1 degree centigrade increase in temperature will have a certain amount of reduction in crop yield. And there are some areas where the susceptibility to yield decline may be more than in other areas. But that decline is expected, feared to happen. There are many estimates out there how much reduction corn yield may happen in sub-Saharan Africa and Asia. Most of them, the estimates vary, but most of those model studies do indicate yield reduction. But it does not have to be. We can adapt agriculture. I wish I had gone into show you a couple of slides from my experiments, both in Africa and in Ohio, where a simple matter of decreasing soil temperature uh, from 40 degrees Celsius in the surface layer to 35 or 33 degree by mulching, reducing evaporation loss from water from soil by mulching, where it would suffer from drought 5 days later. So reducing temperature, increasing moisture content, increasing green water supply, adopting plant varieties with deeper root system. That's what we call climate smart agriculture or climate resilient agriculture. So we do know how to adapt. We can also select species which are more adaptable. So I think, yes, there is a danger, but I think the good thing is that we also know how to adapt, how to mitigate, and we do have a scientific knowledge. This is where I think translating the existing knowledge into action, empowering farmers, especially the women farmers in developing countries and resources, is very critical. And this is where I would salute any policymaker who would empower and help with the farmers. That is what the politics we need at the moment, so that we can mitigate one side but adapt by using the existing knowledge. And we do have the knowledge.
But I think that's part of the humankind story, isn't it? That we
Yeah.
do adapt. We are excellent at resilience and finding ways to adapt to new normals. And I mean, again, your last slide, you said if Gandhi was alive today, he would add technology. And what we know is that there is some remarkable um, advances that are happening with technology and food, particularly in sub-Saharan Africa, along the green belt, along the Sahel. Um, and in fact, to do my own plug, Ismail Saragelden is very passionate about food systems and food resilience. And there was a consultation that happened last week at the UN, which I will share with our team at Indio Bioscience, because I think the listeners today will be very interested in this thought process that is going on, that really ties together climate change, resilience, adaptation, and Professor Lal, your call to policymakers to really listen. So we had quite a broad question about climate change, and now I want to bring it in very specifically, and we're going to have two questions about rice. So the first question is that rice farming involves submerging the entire farm with water, and the demands on water are extensive. Are there other methods to reduce the water consumption in the harvesting of rice?
Yes, absolutely. Um, We have been traditionally growing rice under flooding conditions, aerobic rice, lot of water use, especially in the Indo-Gangetic plain, Pakistan, India, the northwestern part of India and Pakistan, desert areas, semi-desert, and here we have flooded rice where the air temperature is more than 40 degrees, 45 degrees, 43 degrees. A lot of wastage of water. There is a system called aerobic rice, direct seeded aerobic rice without puddling. So you're growing rice just like wheat. It is possible. I believe that that will happen. The yield reduction may be 10% under aerobic rice condition, maybe 12%. It is very likely it may happen. But right now, the question of saving water, the question of reducing emission of methane, which rice paddy is characterized to cause methane emission, which leads to 21 times more global warming potential. I think that's a much better option. The other option is to switch perhaps rice cultivation in humid areas further east on the eastern part of India rather than the desert area on the western part. And another reason, we waste 30 to 40% of the grains, including rice. I've taken picture of the pyramids of rice and wheat in gunny bags protected under a plastic sheet. And one rain, you know what that does. So
Mhm.
why do you keep producing more and more and then keep wasting? Why can't we use properly what we produce, and we do not have to always maximize the yield? So optimize the yield, save water, use modern technology, and make climate smart agriculture also. So yes, rice should be grown under aerobic condition. There are varieties designed for it, but there may be some yield sacrifice, and we can sacrifice yield because we waste so much.
So the next question's at the other end of the rice production. And, one of the things that we're talking a lot more about is the circular economy and what happens at the end, and the importance of having a circular economy for sustainable development and living within planetary resources. So this question is from Nimla Devet Thakur, and they ask, the practice of burning rice stubble in India is creating air pollution. Does it also have an effect on soil health? And if so, can we find some corrective measures? So, Professor, I don't know about the burning of rice stubble, so perhaps you could talk about that first. But I can tell you that
Absolutely.
one of the enduring images I have from this pandemic is of Indian cities where the pollution has dissipated through this pandemic, and people have seen mountains for the first time that have always been in their vision, but it's been hidden by this pollution. So I'd like to know how much pollution is caused by this burning of rice stubble, what it actually means for the flow of the rice cycle.
Alison, thank you. You know, pandemic is a tragedy, but when Delhi was closed down and 11 million cars were off the road and the crop residue was not being burned, first time you could see the mountain peaks, snowy peak from 100 miles away. First time the Ganges water was of a drinkable quality. First time you could see dolphins in Ganges, which were thought to be endangered. First time they saw flamingos in west coast of India. Uh, it means if humans behave not under tragic condition necessarily always, nature does reward, nature does come back. Crop residue burning is something not acceptable. If I were to be a minister of environment and agriculture of India or other countries, I would do the following. Somehow try to find crop residue burning is eliminated. I want to make sure that the flooding rice pad is gone. We have a direct. I want to make sure tops are removal to 1 meter depth for brick making is not done. We'll identify a few sites where you can go deeper and deeper. And I will try to provide clean cooking fuel to the housewives so that the dung is not used for cooking, but goes back to the land and as part of the circular economy to improve soil fertility and not use chemical fertilizer alone. Uh, I would address the issue of afforestation of the lower Himalaya Shivalik hills, all the from Afghanistan to Cambodia, with cooperation through all the countries, so that the drought flood syndrome that all countries suffer flood during the rains, like right now at this time of the year, and no water during the summer. The solution lies in afforestation of the lower hills and
Mhm.
hills everywhere. They should do it. This is where the commonality need to be. So circular economy, yes, we have so much waste. We burn 100 million tons of residue in India, northwestern India alone. Pollution so bad that uh, health issue. There is a statistics on number of death, premature death because of that. The planes cannot land. So how could you accept such an option? So government here should provide technological innovation facilities available. For example, crop residue can be harvested at a ground level by proper harvesters. There can be balers available. Government can provide a rental facility for equipment that smallholders cannot. No-till seeders should be made available so that the burning is not required. The residue which is burnt can be used as an industrial material. It can be composted. It can be pyrolyzed into biochar. It can be used in biodigester to generate energy. It is an asset if we use it properly through the circular economy. We know all that. The question is how to develop a system, how to empower poor farmers so that they can do the technology. And this is what I was thinking. Why not provide at a village level, at a district level, the machinery that farmers can rent? And if you have to subsidize something, rather than subsidizing nitrogen, subsidizing electricity for irrigation pump to wastewater, subsidizing uh, grains which then eventually go rotting because they're not used properly. I think we need to do a proper way to empower farmers through use of better technology so that our agriculture is environment friendly. Agriculture has to be solution to the environment.
Yeah, you're saying exactly the same thing that was said in the consultation last week on food systems, that we must empower local farmers with new technology. Um, there have, Professor, there's been over 50 questions come in, and we're not going to have time for all of them. And so I think it would be likely that um, India Bioscience captures those questions. We might try and put it on a shared drive where people can also crowdsource and fill in the answers themselves.
And I will try to answer them and provide the answer back for everyone to read.
Well, we don't want to take up too much of your time, Professor, but I think there's been a number of questions that have come in that touches on, you know, the what your very first few slides talked about, which was the booming population, the need to feed the world, and how do we do that with the nexus between using fertilizers versus organic farming. So, you know, here we want to have food security. How do we do that? How do we ensure that we find a way forward with the phosphates that we add to the soil? I've heard this described as heroin for soil. Once it's in the soil, it's very difficult for the soil to recover. But at the same time, it provides the nutrients the soil needs to have to yield strong harvests every year. So, can you talk a bit about that? How do we sustain human life
Thank you.
and cultivate enough food without the use of phosphates and things like this?
And phosphate is also a nutrient which many people believe maybe reserves are available perhaps for another 200 or 300 years. And therefore their utilization and recycling is very critical. I want to come back for a minute to feeding the population. Delhi's population has gone up by a factor of 30 since 1950 to, let's say, 2025. Population of every major city's population of Lagos, Nigeria, for example. Lagos, Nigeria will be 80 million people by the end of the century, more than 80 million people. So a city of 10 million requires 6,000 tons of food per day. And all those nutrients coming into the city never get back. In fact, they are a liability, major health hazard because they're not being disposed of properly. And so a circular economy where you recycle the water and nutrient, the black gray water, so-called, by modern kind of urban agriculture, skyscrapers where you have a water of the city sanitized and then recycled in aquaculture, aeroponics, hydroponics, in glass building, even um, fish culture, extra with that algal production for biofuel fertilizer, could be something which becomes a very important part. So that's a recycling. Now, the other part which I think is very important is fertilizer use. India right now uses 165 kilogram per hectare average fertilizer. US uses 100 kilogram. China uses 400 kilogram. Africa uses 12 kilogram, 15 kilograms, something like that. So we have some places like sub-Saharan Africa not using it. You have China using it very high, and we have other using it improperly. 165 kilogram in India, the nitrogen use efficiency, which is subsidized, therefore people buy more nitrogen, phosphorus and potassium, and therefore there's an unbalanced application of fertilizer. So the nitrogen which is applied is not used efficiently. Efficiency of nitrogen used in India may be less than 30%, less. I think it's closer to 20%. The efficiency in China is about 30%. Efficiency in the US is about 40%. Efficiency should go higher. There is no reason why if it is done properly, it should not be 60, 70%. With that, the rate of fertilizer application can decrease tremendously. I realize with the current population of 8 billion, almost 7.8 billion, we probably cannot do without fertilizers. But the fertilizer should be as a supplemental over and above the recycling, the circular economy of biofertilizer. Whatever you need additional, especially the micronutrient fertilizers, zinc, copper, iron, which are holding back the productivity. We have the so-called law of minima, is the mineral nutrient which is least available determine the actual yield. So doing it properly through precision agriculture, we can, and through evaluating and providing soil test data, soil health card that India is proposing, we can definitely increase the efficiency and reduce the rate. And that is the way to go. Uh, I call it integrated nutrient management. Use biofertilizer, mycorrhiza, rhizobium, and then whatever supplemental is needed, use that as a prescription, not indiscriminately and not dumping improperly.
I think we've got time for 2 more questions, if that's okay with you, Professor, or is that okay? Because the audience is very engaged and we've got questions coming in. So I'm going to ask 2 more questions and then I'll bring it back to Shashi and he might have his own questions. So this one's actually about hydroponics, and that hydroponics is an emerging technology that it means that it could assist those crops that actually need soil versus the crops that can be done hydroponically. And I also think back to some of my own studies in climate change, where we looked at seaweed as potentially a miracle crop that could replace wheat in pasta, and at the same time sequester carbon from the oceans. So what's your view on hydroponics? Should we be looking more into finding ways to say, okay, this crop, it really matters for soil, but this crop can be removed from the soil and hydroponics so that we actually have a more symbiotic relationship going on?
I'm really happy you asked that question. You remember during the urban agriculture, I mentioned skyscraper building just to grow food. And in that, I mentioned hydroponic, aquaponics, aeroponic, including aeroponic. I do want to mention something. Soil is a finite resource. Soil is a very precious resource. Right now, we are using soil only for agriculture. Soil has so many other uses. All our antibiotics come from soil. 95% of the antibiotics come from soil. There are so many uses that we even do not know. So such a precious material, so small, being polluted tremendously so that the microbes, their population, their activity changing, we have to find soil-less agriculture. We have to create synthetic soils from newspaper, from cardboard, from lawn clippings, from everything else. We should try to find substitutes for soil. So anything that we can find where we can protect soil for other uses that even we do not know may exist, is a very absolutely important part. So soilless solution, hydroponics, aquaponics, aeroponics, a part of that, I would absolutely recommend it. Let's keep it solve for other purposes and find alternatives.
And I'm going to finish with this last question before I hand back to Shashi. And I think this is a really fitting question to finish on that Fatimatu Zahera has asked. And she says, how important is education of the farmers and their children? And how can we as individuals assist in ensuring that we tend to the soil correctly and that soil has a strong future?
Thank you so much. Thank you. Whoever is asking that question, it's a brilliant question. Education of farmer is very important, especially of the women farmers. 60% of more than 60% farmers in sub-Saharan Africa are women. Quite a majority of the farmers in Southeast Asia are women, and they are not educated. They are very poor. So education is the first part. Uh, that's very critical. Somewhere we should, if we can arrange that the farmers could be given some kind of education, especially that related to agriculture, in relation to weather issue, in relation to disease pattern, low-cost invasion, pricing of the commodity, how to grow, produce properly, how to prepare compost, how to compost the animal and agricultural waste. That's all part of education. Absolutely critical. And that was also I mentioning Gandhi's education without relevance. Um, I think educated women um, is the solution to population. It's absolutely a solution. If they understand, they should have understanding and control and power on their own reproductivity. It's not only agricultural part, but also, so education is really the solution to many humanities issues, and education, especially of the women, education of the farmers. Farmers should understand what modern scientific agriculture is. So I think if I were to translate science of agriculture into practice, so that agriculture is a solution to global issues, sustainable development goal, education is number one part.
Well, thank you very much, Professor Rattan Lal, for your time today. And I'm sure everybody who's been on this webinar, no matter where they are in the world, has really enjoyed this discussion. And I can tell just by the very engaged and animated questions that we have that we've really appreciated your time.
Alison, you are a good moderator and outstanding the way you handle things. So I hope we will repeat it sometime.
Well, I hope so too. And I mean, there's been a team of people that I'm sure Shashi will thank. Before I go, this is a very strong message to those researchers who are online and those students who think they might become researchers and scientists in the future. Join your scientific union. Whether it's the Soil Union that Professor Lau was president of, whether it's the International Union of Biological Sciences that Shashi is part of, your international union champions your science. And together at the International Science Council, we champion all science. And our key, and Professor Lau spoke to this, our key is finding your evidence and presenting that evidence to policymakers so that the technology and the discoveries that you find can become a reality for those everyday farmers that you've spoken about today. So I'm now going to pass on to Shashi. Thank you very much. And I'm looking forward to seeing the recording of this and also finding a way where your questions can be answered. And my suggestion is that we have a shared document that people can answer as well as Professor Lau, so it's not all left up to him. Thank you both. Thank you, Shashi. Over to you.
Thank you. Thank you very much, Alison. You really wonderfully moderated this whole webinar. Thank you very much. Thanks, Professor Rattan Lal. It was a wonderful seminar. We're all glued to the screen. We didn't realize that it has already passed 1 hour. And I see that almost all the participants who are attending this are still there, and I'll still see questions keep coming to the screen. So thank you very much. It was wonderful. I think, as Alison mentioned, I think one we should all do together. ISC, IUSS, International Union of Soil Science, and IUBS, of course. We would be happy to take the lead, both
Sure.
of us, along with ISC, that we should come out with two major international policies, one on soil and one on zoonotic diseases. I mean, I guess you also mentioned it all sort of integrates into one health phenomena at the end. And soil health is the beginning to have the health of the earth. The future earth, it depends on how we tend the soil today. Thank you very much. And I want to formally thank, again, IUBS Executive Council for permitting me to organize this webinar. And also Nathalie Francois, she is the Executive Director and she handled many of the logistics. And more importantly, I want to thank India Bioscience, which is similar to IUBS. It's an organization which connects Indian biological community, whereas IUBS connects the world biological community. And IUBS is promoting biology research and education in India. And Smita, Tejaswini, and Shreya, Manjula, and Lakshmi, they are the ones who helped a lot in taking this forward. Thank you very much to everyone. And thanks to all the audience who patiently heard you. And I'm sure they were very excited, and there's a lot of message they're taking home back today. And there'll be a lot of discussion, I'm sure, over the internet on the importance of tending the soil properly for protecting the earth tomorrow. Thank you very much.
I want to thank you for inviting me. I really appreciated the opportunity of this webinar. Thank you.
Right, thank you, Sashi and Professor Lal and
Thanks also,
Alison.
special thanks to Maggie also, who helped Rattan to put together his talk. Thank you.
All right, so thank you all, and especially the audiences who have joined us. We would love to hear your feedback. So when this webinar closes, you will have a feedback form pop up on your screen. We'll also be sharing this via the chat. So please take a moment while you're fresh with the experience to let us know what you thought. And also submit more questions if you have for Professor Rattan Lal. We'll be sure to take that up. With that, during these times, please do stay safe. And do visit the International Union of Biological Sciences website to learn about all the wonderful work they do in promoting excellence in biological sciences. Goodbye, everybody.